Welcome back to lesson 3.4. It's called exploratory data analysis. So in the previous lesson, we learned basically the 5-number summary. And then we're going to add on to that a picture of that, which is called a box plot. It helps give us a visual of our data. So the 5-number summary is the lowest value of the data set, which is the minimum, the Q1, the median or Q2, and the Q3, and the highest value of the data set, or the maximum. Remember that the Q1 we said was the 25th percentile. The Q2 is P50 or the 50th percentile, and Q3 is P75. This is the same as P25. And this is what they look like in what we're going to call a box plot. You'll also hear it called the box and whisker plot. So the minimum is this far bar right here. If there are any data values that fall outside of the lower fence, they're out here to the left, because this minimum is our minimum here. Now, if there were a value that fell outside of the lower fence, it would be the minimum down here. This bar is called our lower fence, which in this case happens to be the minimum as well. This left side of this rectangle here is our Q1. The median is always the bar on the inside. Now, it's not always in the middle. We're going to go back to our shape and distribution that we've been talking about since chapter 2, but it's the bar in the inside of the box. The bar on the right side of the box is the Q3, and then this far right bar right here is our upper fence. It also happens to be the maximum here. And then it's also to know that this is on a scaled number line so that you can figure out what these values are from the picture. We can create these in Desmos and also in Google Sheets. We're going to use Desmos. I give a little tidbit here about Google Sheets, but it's really mainly Desmos. So in Desmos, if you click the plus button to start a table, enter your data into X1, and then you're going to type the command boxplot X1. Or wherever your data is. If Desmos has created your data into X5, you're going to say boxplot of X5. Do not click the box to exclude the outliers. We do want to include those if there are any. So let's look at one here. The following data are the number of pages in 40 books on a shelf. Construct a box plot using Desmos for the following data set. So I have listed these in Desmos already. This is what it's going to look like. Here is our minimum, our Q1, our median, our Q3, and our max. So if we go to, let's just kind of estimate these, and I'm going to show you how you can verify this in Desmos. So our Q1, it looks like it's just below this line here. Let's figure out how much each of these bars are. So there's 1, 2, 3, 4. So it looks like there's 1, 2, 3, 4, 5 spaces between 200 and 300, which is a distance of 100 divided by 5. So they each must be 20. So this is 220, 240. So I'm estimating this to be about 238 as an estimation. The median looks like it's just above 320. So I'm going to say 321. And the Q3 looks like it's just below 400, but I'm going to say it's at 3. This is going to be 380. So I'm going to say it's at like 397. I'm going to guess my max is between 5. I'm going to say about 512. And I'm going to guess my min is that's 180, 160, 140. So I'm going to say 138. These are all just estimated guesses, and we're going to go to Desmos to see how we can find them exactly. So in Desmos, I have the data here for books on a shelf, pages of books on a shelf. Okay, so I went on here, I made my box plot. I said box plot of X1. I'm going to turn it on. I'm going to go down here. I think I've got another one turned on. I've got it. When they're highlighted, that means they're turned on. So I have to turn this one off. Okay, so this one's turned on. And if you wanted to reset the scaling, you can click on the magnifying glass. And there's the one that we had in our paper. And if you type that stats of X1, it will give you your stats. So it looks like I was pretty close on my guesses for these values. Pretty simple. Okay, while we're here, let's go ahead and flip the page and look at the next one. The following data set shows the heights in inches for boys in a class of 40. And then we also have the heights in inches for the girls in the class of 40. And so I'm going to drop down that, and you can see I put those are in X2 and Y2. So I want to compare them. I need to go up here and turn off this box plot. Okay, so I can go down here and I'm going to turn on, there's the boys box plot, and you can see it's very scrunched because of the scaling. So let's click on our magnifying glass. And then there's the boys, and then I'm going to click on the girls, and you can see the girls on average are shorter than the boys, which we would expect. And you could do turn that off for a minute and say the boys, their IQR is from 68 to 72, which is about 14 inches. Oh no, 4 inches. So 4 inches is their IQR. And now if we look at the girls, we can see theirs is from about 63 to 68. So their IQR is about 5 inches. They're a little bit more spread out than the boys. Okay. Example 3 says, follow the steps you used to graph a box plot for these data shown. So I typed them in here, and we're going to turn on the box plot, and there it is. And now we need to hit the scaling again, the magnifying glass. Okay, there it is. So I'd like you to eyeball these, but I used stat X3 to find out my values here. So let's go back to our paper to answer these questions. What is the minimum? The minimum was 0. What is the Q1? That was 15. What is the median? It was 50. The Q3 is 110. Our IQR is 110 minus 15, or 95. And what is the maximum value? Is 330. And it's a potential outlier for sure. You can see that there. And then example 4 says, find the mean, median, and shape of the distribution. So this is the same data we just looked at. And we need to find the mean and median, which we did not have the stats, and Desmos does not give us that. So let's just go back to Desmos for one last moment here. It did give us the min, the median, the Q1, Q3, and the max. So here's the mean, which is 79, and the median, which is 50. So we're going to tie all of our chapters up together here. So let's go back to our paper one last time. And we can see from the shape of our distribution, it's very much skewed right. The tails on the box plot are thinner over here and longer to the right, so it's skewed right. And we also have this potential outlier. And then we can also see that because our mean is significantly larger than our median, and our arrow in the inequality is pointing to the right, it's skewed right. So we kind of put this all together. Back from lesson 3.2, we've been looking at this. And that's why, because this data is skewed right, we're going to use the IQR as our best measure of spread and our median as our best measure of center. And hopefully you've learned a lot about quantitative data and how we can find statistics and parameters of that data, and how we can use that to measure our shape of our distributions of our data. And that's going to propel us forward for the rest of the semester. Catch me back for another lesson.